Okay, everything we've done so far in doing the integration, we've done the integration with polynomials. Okay, now this is actually, they call this integration by substitution. Okay, it's integration by substitution. And that's like running the chain rule. Backwards. Okay, and I'm going to go through 3 examples of indefinite integrals, and then I'm going to do 1 example of definite integrals, but I'm going to work at 2 different methods. So first, they'll just say evaluate or simplify. Okay. And let's say they give you the integral, and this one's indefinite because there's no a and a b value on there. The indefinite integral of the square root of 3x plus 2, and then with respect to x. Okay, now if we tried to do the indefinite integral the way it is, we don't have a polynomial because of that square root of the whole thing. So right there we're stuck. Okay. So what you do on this integration by substitution is you let parts of your problem equal something else so that you can rewrite it, so that you can substitute in and make it a more manageable, and they call it the integrand. This is actually the integrand, okay, this part. So, and when you first do these, you don't know, they're going to let u equal something. When you first do these, you don't know what to let u equal. And I can tell you I can't say let u equal this all the time. Okay? The only way this gets easier is to do the homework, and then all of a sudden you'll start seeing what to let u equal. Okay? So, on this one, let u equal. If we let u equal the part underneath the radical, 3x plus 2. Okay? Now, we have to substitute in. The problem started out with everything in terms of an x. Now, if we let u equal 3x plus 2, we've got to be able to substitute in for everything in that problem. Okay? So what they do is they take, they call it the differential or derivative of both sides, but instead of writing du over dx, they're going to say the differential of this side would be du. If you take the derivative, now when you're over on this part, you're taking derivative. So this is like take 1 times the number in front, depress that exponent by 1, so that'd be x to the 0. Okay, and then the 2, what's the derivative of 2? 0. So this is like du is the derivative 3 times or 3 with respect to x. I guess I should say it that way. Okay? Now, when you look over here, and sometimes it helps me to highlight. Okay, the 3x plus 2, I can sub in for that. Okay? I also need to sub in, I also need to substitute in for this, the with respect to x. So I've got to get this by itself. Normally we would say divide by 3, but instead of dividing by 3, what they do is they multiply by 1/3 on both sides. So they're going to say 1/3 du equals dx. Okay. Now I can substitute in for everything. So I'd have the integral of the square root of u, and then times 1/3 du. Okay. Now, are you with me there, subbing in? Okay. The next step, I would take that 1/3 out front. Okay. And I don't care if you go across or down, it doesn't matter. If I take the 1/3 out front, that makes it a little bit easier. And the integral of the square root of u with respect to u. I would leave the 1/3 out front, and the integral square root of u is u to what power? u to the 1/2 power, right, with respect to u. Now, if I cover up, you know, if I would cover up all of this and just say start with this, now you're back to a polynomial. Add 1 to the exponent, divide by the new exponent, okay? So if we take the integral of this, leave the 1/3 out front. So if I add 1 to that exponent, it'd be u to the 3/2 power, right? And then divide by 3/2, okay? And then plus some constant, because it's indefinite. Now, it's like this. It's like 1/3 u to the 3/2 divided by 3/2. So it's like 1/3 divided by 3/2. 1/3 divided by 3/2. You have to invert that and multiply. Whoop, oh, sorry. Thinking of the answer. So that'd be 2/9, right? You agree with that? 1/3 divided by 3/2 would be 2/9 u to the 3/2 power plus c. Now, if you started the problem with an x, you have to end with an x. So then you go back and say, okay, u equals that. So now I got to substitute that in for u. So my final answer is 2/9 times the quantity 3x plus 2. That quantity is to the 3/2 power plus c. If they said no rational exponents, okay, if they said no fractional or rational exponents, then it would be the square root of 3x plus 2. And you can have that 3 on the inside or the outside. I could go like this. Okay, so either answer. Either this is with the rational 3/2 exponent, and this is without. Okay. Okay. So that's your first problem on integration by substitution. Okay. Any questions on that one? Once you get it down to a polynomial, then you know how to work it. Okay. Okay. Let's try another example. The only way these get better is to go through and practice them. Okay. Same thing. They will say evaluate. Okay, the integral, indefinite integral x times the square root of x minus 1 with respect to x. Again, you're stuck right there because you can't do anything with that radical. Okay, so you have to decide what to let u equal. Okay, and this the only way you start, let u equal something, you substitute in, you try to figure it out. If it doesn't work, then you let u equal something else. Okay, on this one, we're going to let u equal the square root. Sometimes the u is the part underneath the radical. Sometimes it's the part with the radical. Okay. Now, if part of the reason I'm letting it equal it with the radical, I have to be able to substitute in for this. I have to be able to substitute in for this. And I have to be able to substitute in for this. I got to substitute in for all of it. Okay, so how do I get rid of the square root? Square both sides. So I'd have u squared equals, when I squared this side, all that's going to do is get rid of that radical. So I'd have x minus 1. So far I can put a u in for this. Now I'm trying to get x by itself. So I can substitute in for that. So I need to add 1. So this would be u squared plus 1 equals x. Okay? Okay? Now take the derivative of both sides. Okay? So if I take the derivative of this side, and this would be just, okay, because if I took the derivative of this, it'd just be 1, right? 1 with respect to x. So take the derivative of this would be 2u with respect to u. Derivative of 1 is just 0. Okay, now let me stop there. Okay, so now I should be able to substitute in for everything. Okay, so, and I just, usually the first time I just go right below it. And I usually rewrite it so that the du is at the end, because that's common notation for integration. So the x is u squared plus 1. Okay, so sub that in. The square root of x plus 1 is u, so sub that in. And the dx is 2u du. Okay. Okay, so now, if I simplify this part, okay, just leave the u squared plus 1. This would be 2u squared with respect to u, right? And I can distribute this, distributive property, multiply that out. I'm trying to get it to a basic polynomial. So this would be 2u to the 4th, check my arithmetic, plus 2u squared, put parentheses around it, and then with respect to u. Okay, now if I covered up all the rest of this and all the rest of this and look just at that line, now you're down to a polynomial. That you know how to do the integral. So add 1 to the exponent. I could take out 2 right there, right? I could take out a 2. Whoops, hang on. Back to the 1 again. I could take out a 2, okay, if I wanted to. If I do, if I take a 2 out of that, what's left? U to the 4th plus u squared with respect to u. If that simplifies it, and sometimes that will, if you have several terms, if you can take a constant out front, make it easier. So leave the 2. Now you're going to do the antiderivative. Add 1 to the exponent, so that'd be u to the 5th and divided by 5, plus add 1 to the exponent, du to the 3rd divided by 3, and then plus c. Okay. Now, if you started with an x, you've got an end with an x. So what are u equal? U is this. So you got to sub it in here and here. Okay, so we'd have 2 times the square root of x minus 1 over 5 plus this, whoops, sorry, that's to the 5th power, plus the square root of x minus 1 cubed over 3, and then plus c. Okay? If that's okay to write it like that, if in the back of the book say you got it, that's good for me. Or you could say that is the same as 2/5, the square root of x minus 1 to the 5th, plus 2/3 square root of x minus 1 to the 3rd plus c. They're the same answer. They just look a little bit different. They distributed out the 2. Okay? Okay? So part of it's figuring out what to let u equal. Okay? But you have to be able to substitute in for everything in the problem. Okay? Let's try another one. Everybody done with that one? Okay? Hang on a minute. Full? Okay? Okay, this will be the third example of an indefinite. Okay? And they'll still say evaluate. Okay? The indefinite integral of 9 times the quantity x squared plus 3x plus 5. Close the parentheses. That's all to the 8th power times the quantity 2x plus 3 with respect to x. And you don't have any rules for, a quantity to a power. Okay, so you've got to get that integrand into something that you can work with. Now, if you look ahead and say, what do I let u equal? Okay, if I let u equal the x squared plus 3x plus 5, what is the derivative of this? Right there. Okay, if I let u equal 2x plus 3, what's the derivative of that? And that doesn't help us. You see? You kind of look ahead in the problem. Okay, so let u equal the x squared plus 3x plus 5. Okay. Then du would equal, derivative of this side would be 2x plus 3, and that's with respect to x. Derivative of 5, remember a constant derivative is just 0. Okay? So, now I should be able to substitute in for this. I can substitute in a u. Okay, for this whole thing, I can substitute in a du. The 9 I can take out front. Okay, so let's take the 9 out front. Okay, and then I'd have u to the 8th du. Now you do the antiderivative. Add 1 to the exponent. Leave the 9 out front. So if I add 1 to that exponent, it'd be u to the 9th divided by 9. Okay, and then plus c. And this is like 9 over 1. So these will divide out. They reduce or divide out. So you'd have u to the 9th plus c. If you started with an x, this is the third time I've said it. Have you written it down? All right, somebody's listening. If you started with an x, you got to end with an x. So when you're doing a test or doing the homework, you can't stop here. So u equals this whole thing. So now you got to substitute it in. So we'd have x squared plus 3x plus 5 to the 9th power plus c. Okay? Okay? Before we go through the definite integrals, I want to go back and let's check. Let's go back to the first one. Okay? Okay, everybody done with that one? Okay, go all the way back up to the first problem we did. Okay? Okay, out at the side, the margin somewhere, we went through 2 methods the other day to check. Okay, I want to go back and review those. If I was checking these, and like I said, when you're doing the checks, pick one of these 2 methods and learn it. And use it, the same method all the time, then it'll be easier for you. Like if I was doing one of the checks, I'd do y sub 1, I'd put in the 2/9 times the quantity 3x plus 2 and raise that to the 3/2 power. Okay. In y sub 2, I could do the FNINT, the function integral, and then parentheses, the square root, and I'm just putting in the problem, the square root of 3x plus 2, that's the original problem. Close the parentheses, comma x, comma 0, comma x, close the parentheses. And then in y sub 3, we used the vars key and we went y sub 1 minus y sub 2. This is the one that you turn on. And what should it graph? Should graph a horizontal line. Okay? If it does not graph a horizontal line, then you've got an error. Okay? Remember on some of them with the square roots, it started at 0 and to the right because square roots of negatives are imaginaries. Okay? Now, some of you may not like that method. Okay? If you don't like that method, this is the second way to check. In y sub 1, I could put in the original square root of 3x plus 2. Okay? In y sub 2, I would do the numerical derivative of 2/9 times the quantity 3x plus 2, and that's to the 3/2 power, and that was comma x, comma x. And you want to make sure if you have 4 left parentheses that you have 4 right parentheses. Match it up. And then in y sub 3, put in y sub 1 minus y sub 2. Same thing, you want to turn this one on, and it should graph a horizontal line. Okay? If it doesn't, you've got an error. Okay? So pick one of those methods for the check and learn it. This is probably the part that's different. You're used to putting in comma x on the numerical derivative, but this is a little bit different. Okay. Okay. Now we're going to go through. Did I have a mistake? Okay, now we're going to go through. We've done 3 indefinite intervals by integration by substitution. Now we're going to do. I'm going to do one problem that's a definite interval, and I'm going to show you both methods. Okay. So this, put a separator. This is integration by substitution. Integration by substitution with definite intervals. So that means it's going to have an a and a b. Okay, and remember this you're actually figuring the area underneath the curve. Okay. Okay, this one we're going to do method 1. Okay, and it's still going to say, it's just going to say evaluate or simplify. Okay, and this one is the definite interval. Up in the numerator is x. It's all over the square root of 7 plus x squared with respect to x. And we're going to go from -1 to 3. Okay, it's the definite interval of x divided by the square root of 7 plus x squared with respect to x from -1 to 3. You still have to do integration by substitution. Okay, and you don't really know what to let u equal until you do these for a while. So on this one, we're going to let u equal the 7 plus x squared. Now, if I do that, what's the derivative of that? 2x, right? 2x with respect to x. Can I get x out of that? Yeah, I can multiply by 1/2 on both sides, and that's the idea. You have to substitute in for everything. Okay, so if I take the derivative of both sides, the du, derivative of 7 is just 0, that drops out. This would be 2x with respect to x. Okay, remember you take that exponent times the number in front. Okay, but I need to substitute in. I need to substitute in for this, so I'd have square root of u. But I also need to substitute in for x dx. I need to get that by itself. So multiply by 1/2 on both sides. So 1/2 du equals x with respect to x. Okay. Okay, now on this, don't write down the -1 and the 3. Okay. Okay, it's the integral. Okay, I can sub in that top part. I can substitute in 1/2 du on top. On the bottom, I'd have the square root of u. Okay. The reason I can't substitute, I can't put these down, is because those go with the x, not with the u. So for this method, you just leave them off until the end. Okay. Okay, now if square root of u is u to what power? Yep. So this is like u to the 1/2 power. If I want to move that up, and I'm also going to take this 1/2 out front. Okay, so I'd have 1/2, the integral. If I move this up, it's going to make it u to what power? -1/2, yep, with respect to u. Okay, now it's in a form you can handle. So you leave the 1/2 out front. Add 1 to this exponent would make that u to the 1/2. Okay, so it's u to the 1/2. And the integral symbol's gone. When you start doing the antiderivative, the integral symbol's gone. You add 1 to the exponent, so it's u to the 1/2. Divide by that new exponent. Okay, now don't put the plus c, okay, because we've got values we're going to come back. Okay, so this is actually like 1/2 over 1, right? So what's 1/2 divided by 1/2? 1, right? That divides out with that. 1/2 divided by 1/2. So we're down to u to the 1/2 power. If you started with an x, you got to end with an x. So now we're going to put u back in there. So we have 7 plus x squared to the 1/2 power. Okay, so you sub in the 7 plus x squared, still to the 1/2 power. Okay, now, most of the time on the definite ones, they are going to draw a little bracket on the right side. And now that we're back in terms of x, now we can put these back. So it's from -1 to 3. So remember when we wrote it out twice and then we subbed in the top number? Same idea. So if we sub in the top number, we're going to have the square root of 7 plus 3 squared, and then minus the square root of 7 plus -1 squared, right? So it'd be 7 plus 9. That'd be the square root of 16 minus 7 plus 1 would be like the square root of 8. They are going to simplify those radicals. Okay, so square root of 16, they're going to do 4. And then minus, remember you want to look at the, split that 8 up into like 2 times 4. Out of this you can take out a 2. So you'd have 4 minus 2 radical 2. And that's their final answer. Okay. Okay. So on this method, we substituted in, okay, for u, okay, and then figured everything else and substituted in, and we did not put these numbers down, okay? We just left them off until we were down back in terms of x, then you can put them back in, okay? Okay, now I'm going to work the same problem, method 2, okay? Same problem, another method. Okay, so put on this one method 2. Okay, and the problem was the definite integral of x over the square root of 7 plus x squared with respect to x from -1 to 3. Okay. You still have to substitute in for u, and I'm still going to let u equal the part underneath the radical, the 7 plus x squared. Still do the derivative. Du would equal 2x with respect to x. I still need to substitute in just for this part the x dx, so I'd have 1/2 du equals x with respect to x. Okay. And now here's the difference on method 2. You take this original and write it as a function, as you would write a function. Like if I said y, instead of y, I would write f of x. So I'm going to write this as u of x is 7 plus x squared. Okay? And now sub in your numbers. Put 3 in, so if I did u of 3, it would be 7 plus 3 squared, so 7 plus 9 would be 16. And then sub in -1, so u of -1 would be 7 plus -1 squared would be 8. So these are the values. 16 and 8 are the values that I will use in terms of u. Okay? So you'll write this, the definite integral, and I've just figured the new values are 8 and 16. Okay? So in terms of u, we can substitute in, we still have the square root of u, and the x dx is 1/2 du. Okay. I'm still going to take the 1/2 out front. That just simplifies it. And the integral of du over the square root of u from 8 to 16. Still leave the 1/2 out front, and the integral. I'm gonna move this. Well, I guess I'll do it in one step at a time. So that's u to the 1/2 power from 8 to 16. Still leave the 1/2 out front. Now, if I want to bring that u to the 1/2 power up, it's going to make it negative. Okay. So it'd be u to the negative 1/2 with respect to u. Should look very similar to the other way we did it. Okay, leave the 1/2 out front. Okay, now I'm going to do the antiderivative, so I'm going to add 1 to that exponent, so that would be u to the 1/2 power, divide by the new exponent, divide by 1/2. Now, there's no plus c on here because we have values, and we know what the values are in terms of u, and usually they're going to write it like this, from 8 to 16. They'll put it on the right side. What's 1/2 divided by 1/2? Those will, because this is like over 1, so those will divide out, right? So it's like u to the 1/2 power from 8 to 16. So substitute in the top number first, so it's 16 to the 1/2 power minus, and remember it's always f of b minus f of a, and then 8 to the 1/2 power. So anything to the half power is like square root, so that's square root of 16 minus the square root of 8. Square root of 16 is 4, and this we can simplify to 2 radical 2. So you get the same answer. The only difference is this part, okay, and this part over here. You figure the new values in terms of u. Okay, the first method, we did not write them down until we did the antiderivative, and then we went back to the original values for x. This one, we actually calculate the new values for u and then sub them in. So it should get the same answer both ways. Okay.